Have you ever noticed something strange? Two people can sit in the same classroom, listen to the same teacher, read the same textbook, and spend the same number of hours studying, yet one of them remembers almost everything while the other struggles to recall even the basics a week later. Most people think the answer is obvious. One person is simply smarter. It sounds reasonable. But according to decades of research in cognitive psychology, that's not what usually separates fast learners from everyone else. In fact, some of the people who learn the fastest don't have extraordinary memories at all. They've simply discovered something that most of us were never taught. And once you understand it, the way you study may change forever. Here's the surprising part. Your brain doesn't care how many hours you study. It cares how often you make it work. That sounds like the same thing, but it's actually the complete opposite. Imagine going to the gym. Would you become stronger by watching someone else lift weights? Of course not. You could spend 5 hours watching workout videos every day and never build a single muscle. Your brain works in almost the same way. Reading pages over and over again feels productive. Highlighting important sentences feels productive. Watching another explanation on YouTube feels productive. But in many cases, you're only watching someone else do the mental work. Your brain is surprisingly lazy. Whenever it can avoid effort, it will. And that's exactly why passive studying feels so comfortable. The problem is, comfort is often the enemy of memory. Psychologists even have a name for this illusion. It's called the illusion of competence. The more familiar something becomes, the more convinced you are that you've learnt it. Read a paragraph 5 times, and eventually every sentence starts to feel familiar. Your brain mistakes familiarity for understanding, but familiarity isn't memory. Here's a simple experiment. Read a page from a book. Now close it. Without looking back, try writing down everything you can remember. Most people are shocked by what happens next. They realize they understood far less than they thought, not because they're unintelligent, but because recognizing information is much easier than recalling it, and your brain knows the difference. Recognition is passive. Recall is effort. One gives you confidence, the other creates learning. This single misunderstanding wastes thousands of hours for students around the world. They study harder when they actually need to study differently. But if rereading isn't the answer, what is? To answer that, we need to understand something fascinating about how memories are actually created inside your brain. Because the moment a memory becomes stronger isn't when you first learn something, it's when you almost forget it. The human brain is often compared to a computer, but that's actually a terrible comparison. A computer stores information the moment you save it. Your brain doesn't. Instead, every new piece of information starts out surprisingly fragile. Think of it like writing a message on wet sand. At first, every wave threatens to wash it away. Only after repeated use does that message become carved into stone. And here's the part most people never realize. The process of strengthening a memory doesn't happen while you're reading. It happens while you're trying to bring the information back. Neuroscientists call this retrieval. Every time you struggle to remember something without looking at the answer, the neural pathway connected to that memory becomes a little stronger. It's similar to walking through a forest. The first time you walk, there's no path. The second time, the grass bends. After enough trips, a clear trail begins to appear. Your memories work the same way. The more often your brain has to find a piece of information on its own, the easier it becomes to find it again. Let's test something. Don't worry, this will only take 20 seconds. Think back to the beginning of this video. Without rewinding, can you remember the 3 biggest ideas we've talked about so far? I'll give you a moment. Ready? Most people remember fewer than they expected. And that's exactly the point. The moment you tried to recall those ideas, you weren't just testing your memory, you were strengthening it. This explains something almost everyone has experienced. Have you ever forgotten someone's name only to suddenly remember it hours later while doing something completely unrelated? That wasn't random. Your brain had continued searching even after you stopped thinking about it. And when it finally found the answer, that memory became easier to access the next time. The important lesson is this. Memory isn't built by putting information into your brain. It's built by pulling information back out. This is why some students can spend 6 hours studying and remember less than someone who studied for only 2. The second student isn't necessarily smarter. They're simply forcing their brain to retrieve information more often. Let's imagine 2 different study sessions. Student A reads the same chapter 3 times. Everything feels clear. Every sentence seems familiar. By the end, they feel confident. Student B reads the chapter only once. Then they close the book. They grab a blank sheet of paper and try to explain everything they remember. At first, it's frustrating. They forget details. They make mistakes. They have to think hard. It feels slow. It even feels like they're learning less, but something remarkable is happening. Every struggle tells the brain, this information is important. Keep this pathway alive. Meanwhile, student A's brain receives a completely different message. I've seen this before, not, I need to remember this. That's why difficulty during learning is often a good sign. Not all difficulty, of course. If something is impossibly hard, your brain becomes overwhelmed. But if recalling an answer takes just enough effort, you've entered what psychologists call desirable difficulty. It feels uncomfortable, yet it's one of the most powerful conditions for long-term learning. Ironically, the study methods that feel easiest are often the least effective, and the methods that feel hardest are usually the ones your future self will thank you for. So if struggling to remember is actually helping your brain, why do we spend so much time trying to avoid that struggle? The answer lies in one of the brain's favorite chemicals. And once you understand how it quietly influences your study habits, you'll start noticing it everywhere. Your brain is designed to save energy. Whenever possible, it looks for shortcuts. That's why scrolling through notes feels easier than testing yourself. It's why rereading a chapter feels more comfortable than trying to explain it from memory. Your brain loves familiarity because familiarity requires almost no effort. But learning has never been about comfort. It's about adaptation. Every time you successfully retrieve a memory, your brain sends a clear signal. This information matters. And the more often that signal is repeated, the stronger the memory becomes. This is why one of the most effective study techniques is also one of the simplest. Instead of spending another hour reading your notes, close them, then ask yourself one question. What can I remember right now? Not tomorrow. Not after another review. Right now. Whatever you remember, write it down. Whatever you forget, look it up. Then repeat the process. It sounds almost too simple, but research has consistently shown that active recall outperforms passive review across a wide range of subjects from language learning to medicine. Now, combine that with another powerful principle. Don't review everything at once. Instead, review it just before you're about to forget it. This is known as spaced repetition. Imagine watering a plant. Pouring 10 buckets of water onto it today doesn't mean it will survive for the next month. What it needs is small amounts of water at the right time. Your memory works the same way. A short review tomorrow, another a few days later, then again next week. Each review strengthens the memory just as it's beginning to fade. The result isn't just remembering more, it's remembering for much longer. This is exactly how many language learners memorize thousands of words. It's how medical students retain enormous amounts of information. And it's why people who appear to have amazing memories often aren't relying on talent at all. They're relying on systems. The truth is, fast learners aren't usually reading faster. They aren't studying longer, and they don't necessarily have higher IQs. What they do have is a better understanding of how memory actually works. They know that forgetting isn't the enemy. It's part of the learning process, because every time you fight to remember something, you're telling your brain that it's worth keeping. So the next time you're tempted to read the same page for the 5th time, pause, close the book and see how much you can recall without looking. It might feel harder. It might even feel slower, but that's exactly the point. Learning doesn't happen when information enters your eyes. It happens when your brain struggles to bring that information back. The students who seem naturally gifted aren't always born that way. More often than not, they've simply learned how to learn, and now so have you. If you enjoyed this video and want to discover more science-backed ideas that make learning, thinking, and everyday life a little easier, consider subscribing to Tiny Insights. Because sometimes the smallest insight can completely change the way you see the world.